So today we will discuss trigonometry functions, cosine and sine functions. So we have here a figure with a unit circle. So if theta is an angle in standard position whose terminal side intersects the unit circle at x and y, then the value of your x is equal to the cosine theta and y is the value of your sine theta. The ordered pair x and y can be written as cosine theta, sine theta, which are the coordinates of point P in the figure. Since the unit circle has a radius of 1, your values of x and y can range from -1 to +1. To summarize that, if theta is an angle in standard position, and if x and y is any point other than the origin on the terminal side of theta, then your cosine theta is equal to x over r, and sine theta is equal to y over r, where r is equal to square root of x squared plus y squared. Again, our r here is a radius vector, meaning that is the distance from point P to the origin, meaning that is positive. That's why r is always positive. And x and y can be positive or negative depending on the location of your angle. So here now are the signs of cosine and sine functions. So we have our Cartesian plane with a unit circle, meaning the radius is 1. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. For the quadrant 1, our cosine and sine theta are positive. While in quadrant 2, cosine is negative while your sine theta is positive. For quadrant 3, both cosine and sine theta are negative. While in quadrant 4, cosine theta is positive while sine theta is negative. Example number 1, find the exact values of sine and cosine of an angle theta in standard position if point Q is on its terminal side. Sketch the reference triangle. So how are we going to find the sine and cosine theta of an angle if we are given a point? Like for example, in letter A, we're given a point Q with an ordered pair of 3 and -4. X is equal to 3 and y is equal to -4. If we want to find the cosine theta, that is equal to x over r. If you want to find sine theta, that is equal to y over r. If you will observe our equation, we have the value of x, we have the value of y, but we don't have the value of this r. So meaning, we cannot find the value of cosine and sine theta without finding first the value of this r. And to find the value of that r, we will be needing Pythagorean equation. That is r squared is equal to x squared plus y squared. From this equation, we need to derive an equation for r. And that is equal to square root of x squared plus y squared. So now, let's substitute the given values to our equation. So r is equal to square root of, we replace x by 3, that's why it becomes 3 squared, plus we replace y by -4, that's why it becomes -4 squared. So now let's simplify. So r is equal to square root of 3 squared, that is equal to 9, plus -4 squared, that is equal to 16. And when we add 9 and 16, that is equal to square root of 25. Square root of 25 is equal to +5 and -5. Since r is always positive, so we will get r is equal to +5. So now, we have the value of r is equal to 5, x is equal to 3, and y is equal to -4. So this time, we can now find the value of cosine theta and sine theta. So let's start with cosine theta. So cosine theta is equal to x over r. So we need to replace this x by 3, and we need to replace this r by 5. So cosine theta now is equal to 3/5. So this one is the value for cosine theta. So let's proceed to sine theta. Sine theta is equal to y over r. So we need to replace y by -4. We need to replace r by 5. So sine theta is equal to -4 over 5. Or we can rewrite it as sine theta is equal to -4/5. So this one now is the value of our sine theta. And how are we going to sketch the reference triangle? So here it is. So here is our Cartesian plane and here is our point Q. Since our point Q is equal to, you have an ordered pair of 3 and -4. So from the origin, you count to the right 3 units. So, here it is. And then, this one is negative 4, meaning from origin, pa-down naman tayo 4 units since that is a negative, and then meet mo lang sila, and here now is our point Q. So from here and then from the origin, this one now is our reference triangle, and this one is the arrowhead. Okay, letter B. Again, we asked to find cosine theta and sine theta given point Q with an ordered pair of negative 3 and negative 6. X is equal to negative 3 and y is equal to negative 6. To find cosine theta, that is equal to x over r. To find sine theta, that is equal to y over r. We have the value of x, we have the value of y, but we don't have the value of this r. So again, to find this r, we will be needing Pythagorean equation. That is r squared is equal to x squared plus y squared. So from this equation, we need to derive the formula for r. And that is equal to square root of x squared plus y squared. So this time, let's substitute the given values to our equation. So r now is equal to square root of, replace x by negative 3, that's why it becomes negative 3 squared, plus replace y by negative 6, that's why it becomes negative 6 squared. So let's simplify. So r is equal to square root of negative 3 squared, that is equal to 9, plus negative 6 squared, that is 36. And when we add 9 and 36, that is equal to square root of 45. To simplify this one, so r is equal to 3 square root of 5. Again, r is always positive. So this time, we have the value of r is equal to 3 square root of 5. X is equal to negative 3. Y is equal to negative 6. So meaning, we can now find the value of cosine theta and sine theta. Let's start first with cosine theta. Cosine theta is equal to x over r. Again, we need to replace x by negative 3. And we need to replace r by 3 square root of 5. So here it is. So we have negative 3 over 3 square root of 5. But this time, we can cancel 3, both 3 in numerator and in denominator. So it becomes now negative 1 over square root of 5. Okay, if you will observe, we have a radical expression in the denominator. Again, we don't allow it. So meaning, we need to rationalize this expression by multiplying both numerator and denominator by square root of 5. And to simplify this one, that is equal now to negative square root of 5 over 5. So this one now is the value of our cosine theta. So let's proceed to sine theta. Sine theta is equal to y over r. So we need to replace y by negative 6. We need to replace r by 3 square root of 5. So here it is. So sine theta is equal to negative 6 over 3 square root of 5. Again, we can cancel 6 and 3. So our 6 now becomes 2 and 3 becomes 1. So it becomes negative 2 square root of 5. Again, we have a radical expression in the denominator, meaning we need to rationalize the expression by multiplying both numerator and denominator by square root of 5. And to simplify this one, we have now sine theta is equal to negative 2 square root of 5 over 5. So here now is the value of our sine theta. And to sketch the reference triangle, again, here is our Cartesian plane. Here is our point Q. We have an ordered pair negative 3, negative 6. So let's have the x first. Since this one is a negative, from origin to the left naman tayo, 3 units. And then we have negative 6, meaning from the origin, pa down din, 6 units. And then pag-meet mo lang sila, and here now is our point Q. So here is our reference triangle, and for the arrowhead, since this one is standard position from the initial side to the terminal side. So that is the answer. Let's have example number 2. Angle theta is in standard position with its terminal side in the third quadrant. Find the exact value of cosine theta if sine theta is equal to negative 3/5. For the solution of this problem, since we are given sine theta is equal to negative 3/5 and we know that sine theta is the value of y over r. Again, r should be positive, and since our theta is in third quadrant, your y should be negative. So meaning this numerator now is the value for y. So y now is equal to negative 3. And this denominator is the value of your r. So r now is equal to positive 5. And since we are asked to find cosine theta, that is the value of x over r. We have the value of this r, but we don't have the value of this x. So meaning, before finding cosine theta, we need to find first what is the value of x. To find the value of that x, we will be using Pythagorean equation, and that is x squared plus y squared is equal to r squared. And since we have the value of this y and this r, so let's substitute the given values to our equation. So we have now x squared plus, we replace y by negative 3, that's why it becomes negative 3 squared, equals, we replace r by 5, so it becomes 5 squared. So let's simplify now. So x squared plus negative 3 squared, that is equal to 9, equals 5 squared is equal to 25. And this time, we will use the SPE or subtraction property of equality. So, subtract both sides by 9. So, x squared now is equal to 16. And to find the value of x and eliminate this exponent, which is 2, so i-radical natin both sides. So, x now is equal to square root of 16. And to simplify this one, x now is equal to positive 4 or x is equal to negative 4. Since our x is located in third quadrant, meaning your x should be negative. So we will get x is equal to negative 4. So that is the value for x. So meaning, we can now find the value of this cosine theta since we have the value of this x. So replace x by negative 4 and we'll replace r by positive 5. So cosine theta now is equal to negative 4 over 5, or we can write it as cosine theta is equal to negative 4/5. So here now is the value of our cosine theta. Let's have another problem. So angle theta is in standard position with its terminal side in the first quadrant. Find the exact value of sine theta if cosine theta is equal to 12 over 13. For the solution of this problem, since we are given cosine theta is equal to 12 over 13, and when we say cosine theta, that is the value of x over r. Again, remember that r is always positive, and since your angle theta is located in the first quadrant, meaning your x should be positive. So, in our given, cosine theta is equal to 12 over 13. This numerator is the value of your x, so x now is equal to 12. And this denominator is the value of your r, so we have now r is equal to 13. We're asked to find sine theta. Sine theta is equal to y over r. We have the value of this r, but we don't have the value of this y. So meaning, before finding sine theta, you need to find first what is the value of that y. To find the value of that y, we will be using Pythagorean equation, that is x squared plus y squared is equal to r squared. We have the value of this x, we have the value of this r. So let's substitute. So we replace x by 12, that's why it becomes 12 squared, plus copy y squared is equal to, we replace r by 13, that's why it becomes 13 squared. So next, let's simplify. So 12 squared is equal to 144 plus we copy y squared is equal to 13 squared is equal to 169. So this time, we will use the SPE or subtraction property of equality. We subtract 144 both sides. So meaning this one becomes 0. So y squared now is equal to 169 minus 144. And to subtract this one, y squared now is equal to 25. To find the value of y, so y now is equal to square root of 25. To simplify the square root of 25, y is equal to positive 5 or y is equal to negative 5. To choose between these two values, look at your angle theta that is located in first quadrant, and in first quadrant, your y should be positive. So we will be using y is equal to positive 5. And so we have now the value of y, meaning we can now find the value of this sine theta. By replacing y by 5 and replacing r by 13. So we have now sine theta is equal to 5 over 13. So that is the value of our sine theta.